Welcome to Signals and System subject classes. Now we are in the chapter 3, that is continuous time Fourier series. In the last 3 videos, we have discussed about Fourier series representation and its problems on the Fourier series coefficient. In the third video, we have discussed about some properties. We are discussing the properties of the Fourier series. Now, the remaining properties we have to discuss in this class. So in last class, the last property number, that is 7th one. Now this is 7th one, now 8th. So this 8th property, conjugation, complex conjugation. So the 8th one is conjugation. Complex conjugation, you know that complex conjugation is what? Generally, for example, one complex number, for example, A plus J into B, this is a complex number, is it? You take this is capital A, so complex conjugate. So complex conjugate, this is denoted by the star on the top of the letter, so that equal to the A minus J into B. So it is called complex conjugate of the A, is it? So similarly in conjugation, complex conjugation in the Fourier series, for example, so x of t, and in the x of t, its Fourier series coefficient is AK. Now I am applying the complex conjugation to the signal. So what is the corresponding Fourier series coefficient for this signal, is it? For that proving, so I'm taking the Fourier series representation. So that is x of t equal to, so sigma ak into, so e power, so jk omega naught into t, k from, so minus infinity to plus infinity, is it? So I'm applying the complex conjugate on the left side and right side, is it? So x of t complex conjugate, so sigma, so this is a sigma, k equal to minus infinity to, so plus infinity, so ak into, so e power jk omega naught t into, so complex conjugation. So here we have the two functions, is it? Split to the, so k minus into plus infinity. So ak complex conjugate. So e power, already this is the complex number. So apply the complex conjugate, then so the j gets the minus, is it? Minus j k omega naught into t, is it? So this is x of t complex conjugate. So the signal must be in positive. So is it? So I'm writing like this, k equal to minus infinity, so plus infinity, so ak complex conjugate, so e power j and minus k by omega naught into t. So now here I am going to replace the k by the minus k. So a minus k complex conjugation. So e power jk omega naught into t. So there is no change in the limits, is it? So why? Because it is starting from the minus to infinity, so same. So x of t. So this a minus k complex conjugate is the Fourier series coefficient for the x of t complex conjugation, is it? So ak a minus k complex conjugation, is it? So this is a property. Next, the 9th one, differentiation. So differentiation in the time domain, is it? Differentiation. So in the differentiation, the time domain, I'm taking the x of t, it's a Fourier series coefficient is ak. So you should write Fourier series and Fourier series, is it? Yeah, Fourier series and Fourier series. Fourier series, here this is Fourier series. Now the d by dt, differentiation of the x of t, its corresponding Fourier series coefficient is what? Is it? That is a question. For that, again I'm taking the Fourier series representation. So x of t equal to, so sigma ak into e power jk omega naught into t, k from minus infinity to the plus infinity. So apply differentiation on both sides. So d by dt of x of t, so sigma, so k from minus infinity to plus infinity, is it? Sorry, we are applying the differentiation. So d by dt of, so d by dt of, so sigma k equal to minus infinity to plus infinity ak into e power jk. We apply the differentiation. So this is the summation. So it becomes the partial differentiation. So in partial differentiation with respect to t, so ak is a constant, is it? So dou by dou t into e power jk omega naught into t, k from minus infinity to plus infinity. So that equal to, so sigma ak. So we're doing the differentiation with respect to t. So jk omega naught is a constant, is it? So jk omega naught into e power jk. After the differentiation, we got like this, is it? So this is d by dt of, so x of t. So d by dt of x of t, its corresponding Fourier series ak into jk omega naught. So jk omega naught is multiplied the ak, is it? So Fourier series coefficient. So jk omega naught into ak, is it? In 10th one, integration, the same concept. So that is integration. So the same concept what we applied for the differentiation, same. So in differentiation multiplication we got it. So for the integration here, that k jk omega naught, it must be divided, is it? So x of t Fourier series coefficient is ak. So Fourier series. So integral of x of tau into d tau from 0 to t. See, so this is minus infinity to t. So the corresponding, we will get ak by jk omega naught. Is it? So now the next one, complex conjugate symmetry. Conjugate symmetry. Conjugate symmetry. Conjugate symmetry for real signals. Here our x of t is real. So real signals. Real signals, is it? So here the x of t, its Fourier series coefficient is ak, is it? So the conjugate symmetry. So now this x of t is real. Then so this is a real. So a minus k is a complex conjugate, is it? So this is a real. So real complex conjugation is x of t, is it? So that equal to ak, is it? Real part of ak. So real part of for example real part. I'm going to comparing the ak and a minus k. So same real part of a minus k, is it? So a minus k is what? So for example, ak equal to something. Ak is a real signal, real part of the signal. J into bk, is it? So a minus k nothing but ak minus j into bk, is it? So real part of both real part of equal. So imaginary part. So imaginary part of ak, it is equal to minus imaginary part of a minus k. The magnitude of ak equal to the magnitude of a minus k. There is no change. Why? Because under root of ak square plus bk square, here also under root of ak square plus bk square. But angle, that is 90 degrees different, 180 degrees differentiation. So angle of ak, it is equal to minus angle of a minus k. So these are the properties. Whenever the x of t is real, so this ak and a minus k relation, is it? The 12th one, for the real and even signal, the x of t is real and even signal. X of t real and even signal, is it? So what is the even, actually even and odd? For example, if for example f of minus x, if it is equal to the f of x, then that signal is called, this is, if this function is called even function, is it? This f of minus x is equal to minus f of x, so this function is odd, is it? So this is a even and odd. So you know that real and complex, is it? So the real and even signal. So what is the Fourier coefficient? For example, so x of t, it is Fourier coefficient is ak. Now our x of t is real. X of t real and even. Ak also. So the ak also real and even. If x of t is real but odd, is it? AK becomes complex, purely imaginary. Purely imaginary, and odd, is it? So once the x of t is odd, the real becomes complex. Similarly, we can write, x of t is complex and even. So there is no same, there is no change in the Fourier coefficient. AK also complex and it is even. So now the x of t is complex, but it is odd. Then, so we know that. So AK is now real. So real and the signal is odd. Is it? So this is a real and even signal. Next, 12th. Actually, this is the 13th one. So this is 13th one. Real and odd. So 14th, even and odd decomposition of real signal. So even and odd decomposition is nothing but even part of the signal and odd part of the signal. So what is the meaning? So see, for example, x of t is a real signal, is it? So this is a real signal. So this even part, so even part of x of t is nothing but x of t plus x of minus t by 2. Is it? So odd part x of t that equal to x of t minus x of minus t by 2. This is odd part of the. If you add this even part and odd part, then you will get the same x of t. Is it? So x of t. So first, this x of t, its Fourier series coefficient. So its Fourier series coefficient is ak. So even part, is it? So even part, even part are, so even part of x of t. So that equal to, it is equal to, so this is a complex number. So real part of ak. So similarly, odd part of x of t, it is equal to j into imaginary part of ak. This add this two even part odd part that equal to x of t, is it? So add this real part of ak plus j into imaginary part of ak, you will get the ak. Is it? If so, for the complex number, is it? So directly he may ask question like this. For example, one problem, simple one like x of t is a periodic and real signal. Its Fourier coefficient Fourier series coefficient is AK plus J into BK, that equal to AK. Then Fourier series coefficient of x of t plus x of minus t by 2. Is it? So we know that x of t plus x of minus t by 2, this is a even part. It is even part. So from the even part of x of t, so this is x of t plus x of minus t by 2. So this is even part of x of t, is it? So its Fourier series coefficient equal to, so real part of AK, is it? Here this AK equal to A capital AK plus J into BK. So that equal to the real part of AK equal to AK, is it? So this is a simple question. So next last property, that is Parseval's relation. It's very important. So it is a relation between the power between time signal in time and the frequency domain signal, is it? Parseval's relation. So this Parseval relation, it is a relation between the continuous time signal and frequency time signal in terms of the power, is it? So here for the to remembering this concept, so power between the time and frequency domain. So you know the power. So for example, so V of t is a voltage. So I of t is a current. Is it? So so V of t instantaneous voltage, I of t instantaneous current. The so power equal to instantaneous power equal to V of t into I of t. So V of t is nothing but I of t into R, is it? So I square of t into R, or V square of t by R, is it? So here we can understand that. So power is nothing but square of the one signal. Square of the signal, it always gives the power. Is it? R is the constant, is it? So here also same. So x of t mod x of t square. So this is the power. If you do the integration, so it gives the energy, is it? Again, if you do the 1 by, if you divide by the t, so it gives the average. So again, it becomes the power, is it? So that equal to same AK square sigma k from the minus into plus infinity, is it? So how to remember this formula? See, so x of t, left side is x of t, right side is the AK. So x of t equal to sigma, Fourier series representation, that equal to sigma AK into e power j k omega naught. Is it? The mod of e power j k omega naught, it goes to 1, is it? So AK square. Next AK formula. What is the AK formula? AK equal to 1 by t integral of t x of t into dt, is it? But in this power relation, just you take the square. The mod of the exponential goes to 1, is it? So this is so this Parseval relation we will get in the discrete time Fourier series, and Fourier transform in the continuous time, Fourier transform in the discrete. Same Parseval, is it? So you should remember. So x of t formula and AK formula. Just take the square and square. Remove the exponential. Why? Because the exponential mod of the exponential, it becomes the 1, is it? So this is the Parseval relation. It's very, very important. So Parseval relation is nothing but power relation between the continuous time signal and frequency domain signal, is it? So this is about the properties of the continuous time Fourier series. Thank you.